This bot just reviewed a PR, dropped 4 inline comments and flagged a hard-coded API key. Everything in 11 seconds from start to finish. You know that feeling. You wake up to 15 PRs sitting in your queue. Half of them are AI generated. They look fine on the surface, but nobody has time to actually read the diffs. So today we are building a bot that reads them for you, posts inline comments and catches what a tired reviewer would miss. So here is how it works. We are using GitHub Actions to fire off a Python script every time someone opens a PR. The script grabs the diff, hands it to Claude with a Pydantic schema that defines what a review looks like and gets back structured findings. Then we post those findings as inline comments on the actual lines of code. That is the whole loop. Here is the part that matters. The Pydantic schema is what keeps Claude honest. Without it, you would get back a wall of markdown that you would have to parse with regex. With it, you get a clean list of findings. Each one has a severity, a line number and a suggested fix. Basically, structured output turns Claude from a chatbot into an API. Alright, let's build it. Alright, let's get into the fun part. This is the schema we talked about. It's what turns Claude from a chatbot into something predictable. A finding has 6 fields. Severity tells us how urgent it is. File path and line tells us where to drop the comment. Category lets us filter, like only blocking on security issues. And the message and suggestion are the actual review content. Notice the literal types. They lock Claude into a fixed set of values, so it can't invent new severity levels. The review wrapper just holds a summary plus the list of findings. Now let's implement the reviewer. We are pulling 4 environment variables. The Claude key, the GitHub token, the repo name and the PR number. GitHub Actions injects the repo and PR number for us automatically when the workflow runs, so we just read them as environment variables. We initialize the Claude client and the GitHub client once at the top so we can reuse them across all functions. Now we grab the PR and pull out the diff. PyGithub gives a get files iterator and each file has a patch attribute with the actual diff text. Notice we are skipping deleted files because there is nothing to review there. And we are only keeping the patch and not the full file contents. There are 2 reasons for that. First, Claude only needs to see what changed. Second, sending the entire repo would blow your token budget on big PRs. This is the part that actually does the review. We flatten the files into one big diff string, then send it to Claude with our schema attached as a tool. The tool choice forces Claude to call submit review, which means it has to return a valid finding list. There is no freeform text and no parsing. Notice we are using model JSON schema. Pydantic spits out the JSON schema for us, so we don't have to handwrite it. Then we pull the tool-use block from the response and validate it back into a review object. Now this is where the comments actually land on the PR. If there are no findings, we just drop a single summary comment and bail. Otherwise we post the summary first, then loop through the findings and post each one as an inline comment on the exact line. The key detail here is the site equals write parameter. That tells GitHub to attach the comment to the new version of the file and not the old one. And notice the try except. If a line number doesn't map cleanly to the diff, GitHub returns 422. We just log it and keep going instead of crashing the whole review. And here is main. We fetch the PR, bail early if there is nothing to review, run the review and post the comments. Pretty boring orchestration code. The if name equals main block at the bottom is what lets GitHub Actions just call python reviewer.py and have it work. Now this is the last piece of code. We put it inside .github workflows folder. This is the workflow YAML. It triggers on every pull request and commit to that PR. We check out the code, install our 3 packages and run the script. The environment block is where we wire in the secrets. We manually specify the Anthropic API key and I will show you how later, and GitHub token is auto-provisioned by Actions. The PR number also comes from the event payload, which Actions exposes GitHub event pull request number. So let me show you how to set environment variables. You go to your repository, settings, then you go to secrets and variables and click on Actions. There you will see this repository secrets. You just press new repository secret, you specify the name and the secret value, and that's it. Now back to the code. Let's start by creating a new branch and call it test. Then we'll create one new file and just call it password. Here we can put something like dbpassword equals 12345. This will be the change that we want Claude to see and warn us about. Now let's just commit this. Let's do git add dot git commit. Let's specify the messages test commit and let's push it. We also need to specify the upstream because this is not a tracked branch. Alright, back to GitHub. Now we compare and create a pull request. Let's just name it test commit and create. After some seconds, you'll see that the review will start running. Let's open it. When it's done running, you'll see that it has posted one review comment. Let's go back to the PR and see what it is. So great, you can see that it has flagged a critical security issue. It says that plaintext database password is committed directly to the repository, and this exposes sensitive credentials to anyone with repository access, including in perpetually via Git history. You can see how smart it is. And that is really useful when you have massive PRs generated by AI coding assistants. This workflow can save you many hours of work. So now you have got a working code reviewer that runs on every PR you open. It fetches the diff, runs it through Claude with a structured schema, and drops inline comments right where the issues are. Security smells, complexity problems, missing tests are all flagged automatically. And the whole thing is like 150 lines of Python sitting in your .github folder. From here, you can tune the schema to catch whatever your team actually cares about, like specific anti-patterns in your code base, or wire it up to block merges on critical findings. If you want more agent stuff like this, hit subscribe. I'll catch you in the next one.